Today's daily question is minimum number of pushes to type word second. You're given a string word containing lowercase English letters. Telephone keypads have keys mapped with distinct collection of lowercase English letter which can be used to form word of by pushing them. For example, the key 2 is mapped with ABC. Key 2 is being mapped with ABC. We need to push the key one time to type A and two times to type B. If the character is placed at the second position, then you have to be pressing it twice. The 2 key twice you have to be pressing, and three times to type C. It is allowed to remap the keys numbered 2 to 9 to distinct collection of letters. The key can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Written the minimum number of pushes needed to type word after remapping the keys. An example mapping of letters of keys on a telephone keypad is given below. Note that 1 star and hashtag and 0 do not map to any letters. These should be left as it is without any mapping. The numbers from 2 to 9 should be mapped with the characters. Let's look at the visualization on how we could solve this. Okay, so the core idea is the most frequent letter should be placed at the cheapest position. Cheapest position in this sense, you should be able to type that character using one push. So you'll be placing the most frequent letters at the first uh, first place of all the 8 numbers. So first 8 unique letters will have push of 1, and next 8 will have two unique pushes. I hope you guys got what is that. See, if you're placing the characters at the first position, like A over here, B over here, C, D over here, E, P, T, W, you can get these characters just by one push of the keypad. But if you want other letters, then you have to press 2 for 2 times. You have to be pressing key 2 to get F. And same way, if you want to get H, then you have to be pressing 3 twice. That's how it works. Now I guess the core idea is understood. Now let's visualize it. So let's consider this is the given string. This is the given string and the frequency map. First of all, we'll need a hash map to calculate the frequency of the characters in the given string, and then we'll create a priority queue in order to get the maximum frequent element letter at the starting position, max heap. Then we traverse through the max heap, and then we align the first 8 characters to the first position of the 8 numbers in our keypad. So let's consider these as our first 8 characters, and we place it against 2 to 9. Okay, so that these characters get the push of 1. And if there are more than 8 characters in our given string, then we add the remaining element to the second push position. And to calculate the pushes, first 8 frequency will be calculated like you just have to add all the frequency into 1. You'll be getting the total frequency as 18, and the remaining frequency you will have to multiply. You have to add all this, but here right now we are having only one element, so you'll be adding 1 into how many pushes? 2 pushes. and you'll return that much. Total will be the total of 1 pushes plus total of 2 pushes. You'll be getting 18 plus 2 is equal to 20. I hope you got how we got 18 over here. That is because we have to add all this, which adds up to 18, and into the number of pushes, which is 1. That's how you get 18. And to get the total of this, you add this with the total pushes, which is 1 into 2, you get 2, and then at the end you have to add 1 push plus 2 push, you'll get 20 pushes. Now moving on to the algorithm. So you have to count the frequency using the hash map, then add frequencies to max heap. This is how you'll get the maximum frequent element from the string. Then remove the highest frequent first, because you have to give the minimum position to it so that you get the push has 1. Then we need to calculate the cost. How many pushes is what this gives us, and then you have to multiply frequency with the cost to get the total push. Now let's code this out in our code editor. First we'll need a hash map, character integer. I had put comma over here. Map is equal to new hash map. Then we'll need an integer called push, which we will assign it to 0. And then for char c word dot to char array. And then we need to calculate the frequency. Map dot put c comma map dot get or default c dot comma 0 plus 1. Okay, this is how we'll get the frequency. Now we need to declare a priority queue. Integer, where we'll be storing the frequency. So it's integer. PQ is equal to new priority queue. We have we'll do this because our hash map is not in order. It's not in order, so it's better to use this function reverse to get the max heap. Reverse order. Okay, now we'll add the elements to our priority queue. Add all map dot values. Oh shit. Okay, now we'll have all our frequencies stored in priority queue. Then we will have to have a while loop until our priority queue pq dot is empty. Until it's empty, we need to calculate the value of push, which is equal to push is equal to 1 by 8 plus 1. We'll have one more bracket over here. Into pq dot poll. You'll get the maximum frequency first, getting polled. And then, the value of I we need to declare. Int I is equal to 0. That's all. We'll return our push. Return push. Get or default. Default D is caps. Yep. Now let's talk about complexity. So let's consider yen to be the word length and u is the unique letters. Maximum characters are 26 because we are considering only lower English characters, right? The time complexity will be big O of yen because we count the frequency of yen characters, right? And then heap operation is only for unique characters, it's not for all the yen characters. So it becomes u log u for, but u is always, not always, it's less than or equal to 26. It's always less than or equal to 26. Need not be like it cannot, it should always be less than 26. It is less than or equal to 26 because it cannot be greater than 26 because we have only 26 English lower characters, right? So it's constant. So overall time complexity will be big O of n. Now, moving on to the space complexity, we are using HashMap with the maximum entries as 26 and max heap also with the maximum um, values of 26. So 26 is a constant, so our space complexity becomes big O of 1. Thank you.